the name of the topic is water resources. So in this video, we are going to learn about the following things. First, we will discuss about the concerns which are related to water resources. Second, we will discuss about the reasons for water scarcity. Third, we will see if there are any other threats to water scarcity. Fourth, we will discuss about the conservation of water resources. Fifth, we will discuss about the importance or the significance of dams. Sixth, we will discuss about the concerns regarding the multi-purpose projects and the large dams. Then we are going to talk about the concept of rainwater harvesting. And lastly, we will be discussing about the bamboo drip irrigation system. So let us start. Let us first talk about the concern that is related to the water resources. 3/4 of the Earth's surface is covered with water, but only a small proportion of it accounts for the fresh water that can be put to use. This fresh water is mainly obtained from the surface runoff and the groundwater, which is continuously being renewed and recharged through the hydrological cycle. All water moves within the hydrological cycle, ensuring that water is a renewable resource. Despite 3/4 of the world is covered with water and is water as a renewable resource, still countries and regions around the globe suffer from water scarcity. Also, it has been predicted that by 2025, nearly 2 billion people will live in absolute water scarcity. The availability of water resources varies over space and time, mainly due to the variations in seasonal and annual precipitation. But water scarcity in most cases is caused by overexploitation, excessive use, and unequal access to water among different social groups. So this was the concern related to water resources. Now, let us move ahead and discuss about the reasons for water scarcity. Water scarcity may be an outcome of large and growing population and consequent great demands for water and unequal access to it. A large population requires more water not only for domestic use but also to produce more food. Hence, to facilitate the higher food grain production, water resources are being overexploited to expand the irrigated areas for dry season agriculture. Irrigated agriculture is the largest consumer of water. Now, it is needed to revolutionize the agriculture through developing drought-resistant crops and dry farming techniques. Post-independent India witnessed intensive industrialization and urbanization, thereby creating vast opportunities for us. Today, the large industrial houses are as commonplace as the industrial units of many MNCs, that is, the multinational corporations. The ever-increasing numbers of industries has made matters even worse by exerting pressure on the existing fresh water resources. Industries, apart from being heavy users of water, also requires power to run them, and much of this energy comes from the hydroelectric power. Today, in India, the hydroelectric power contributes approximately 22% of the total electricity produced. Moreover, the multiplying urban centers with large and dense populations and urban lifestyles have not only added to water and energy requirements but have further aggravated the problem. So, after knowing about the reasons for water scarcity, now let us see if there is any other threat to water scarcity. So, apart from the quantitative aspects of water scarcity, there is other situation where water is sufficiently available to meet the needs of the people, but the area still suffers from water scarcity. Now, why could this be a scarcity? Well, this scarcity may be due to bad quality of water. Lately, there has been a growing concern that even if there is ample water to meet the needs of the people, much of it may be polluted by domestic and the industrial waste, that is the chemicals, pesticides, and fertilizers which are used in agriculture, thus making it hazardous for human use. India's rivers, especially the smaller ones, have all turned into toxic streams, and even the big ones like the Ganga and Yamuna are far from being pure. The overexploitation and the mismanagement of water resources will impoverish this resource and cause ecological crisis that may have profound impact on our lives. So, after knowing about the threat to water scarcity, let us discuss about conservation of water resources. The need of the hour is to conserve and manage our water resources so as to safeguard ourselves from health hazards, to ensure food security, continuation of our livelihoods and productive activities, and also to prevent degradation of our natural ecosystems. Archaeological and historical records show that from ancient times we have been constructing sophisticated hydraulic structures like dams built of stone rubble, reservoirs or lakes, embankments and canals for irrigation. We have continued this tradition in modern India by building dams in most of our river basins. Few examples of the hydraulic structures in ancient India are A. In the 1st century BC, Sringaverapura near Allahabad had sophisticated water harvesting system channeling the flood water of river Ganga. B. During the time of Chandragupta Maurya, dams, lakes and irrigation systems were extensively built. C. Evidences of sophisticated irrigation works have also been found in Kalinga, Odisha, Nagarjunkonda, that is Andhra Pradesh, Benur, that is Karnataka, Kolhapur, that is Maharashtra, etc. D. In the 11th century, Bhopal Lake, one of the largest artificial lakes of its time, was built. And finally E. In the 14th century, the tank in Hauz Khas, Delhi, was constructed by Iltutmish for supplying water to the Siri fort area. So, after discussing about some of the conservation measures for water resources, let us understand about the importance or the significance of dams. Dams were traditionally built to impound rivers and rainwater that could be used later to irrigate the agricultural fields. Today, dams are built not just for irrigation but for electricity generation, water supply for domestic and industrial uses, flood control, recreation, inland navigation, and fish breeding. Hence, dams are now referred to as a multi-purpose projects where the many uses of the impounded water are integrated with one another. For example, in the Satluj-Beas river basin, the Bhakra Nangal project water is used both for hydropower production and irrigation. Similarly, the Hirakud project in the Mahanadi basin integrates conservation of water with flood control. In other words, the multi-purpose projects which are launched after independence with their integrated water resources management approach were thought of a vehicle that would lead the nation to development and progress, overcoming the handicap of its colonial past. Also, Jawaharlal Nehru proudly proclaimed the dams as the temples of modern India, the reason being that it would integrate the development of agriculture and the village economy with rapid industrialization and the growth of urban economy as well. Dams are classified according to the structure, intended purpose or the height. Based on structure and the materials used, dams are classified as timber dams, embankment dams or masonry dams with several subtypes. Similarly, according to the height, dams can be categorized as large dams and major dams, or alternatively as low dams, medium height dams and high dams. So after we have understood about the importance of dams, now let us see if there is any concern regarding the multi-purpose projects and these large dams. In recent years, Multi-purpose projects and large dams have come under great scrutiny and opposition for a variety of reasons. Regulating and damming of river waters have affected their natural flow, causing poor sediment flow and excessive sedimentation at the bottom of the reservoir, resulting in rockier stream beds and poorer habitats for the river's aquatic life. Dams also fragment the rivers, making it difficult for aquatic fauna to migrate, especially for spawning. The reservoirs that are created on the floodplains also submerge the existing vegetation and soil, leading to its decomposition over a period of time. Multi-purpose projects and large dams have also been the cause of many new environmental movements like the Narmada Bachao Andolan and the Tehri Dam Andolan, etc. The resistance to these projects has primarily been due to the large-scale displacement of the local communities. The Narmada Bachao Andolan or Save Narmada movement is a non-governmental organization, an NGO, that has mobilized the tribal people, farmers, environmentalists and human rights activists against the Sardar Sarovar Dam being built across the Narmada River in Gujarat. It originally focused on the environmental issues which are related to the trees that would be submerged under the dam water. Recently, it has refocused the aim to enable the poor citizens, especially the outseas, that is, the displaced people, to get full rehabilitation facilities from the government. The Sardar Sarovar Dam has been built over the Narmada River in Gujarat, and it is one of the largest water resource projects of India, covering 4 states, namely Maharashtra, Madhya Pradesh, Gujarat and Rajasthan. The Sardar Sarovar project would meet the requirement of water in the drought-prone and desert areas of Gujarat, that is around 9,490 villages and 173 towns, and even in Rajasthan, somewhere to 124 villages there. We should also note many other concerns, such as: first, irrigation has also changed the cropping pattern of many regions, with farmers shifting to water-intensive and commercial crops. Second, this has great ecological consequences like the salinization of the soil. At the same time, it has transformed the social landscape, that is, increasing the social gap between the richer landowners and the landless poor. Third, as we can see, dams did create conflicts between people wanting different uses and benefits from the same water resources. Fourth, in Gujarat, the Sabarmati Basin farmers were agitated and almost caused a riot over the higher priority given to water supply in urban areas, particularly during droughts. Fifth, the interstate water disputes are also becoming common with regard to the sharing the cost and the benefits of the multi-purpose project. Sixth, for example, the Krishna Godavari dispute is due to the objections raised by Karnataka and Andhra Pradesh government. Seventh, it is regarding the diversion of more water at Koyna by the Maharashtra government for a multi-purpose project. This would reduce downstream flow in their states with adverse consequences for agriculture as well as industry. Eighth, also, most of the objections to the projects arose due to their failure to achieve the purposes for which they are built. Ironically, the dams that were constructed to control floods have triggered floods due to sedimentation in the reservoir. Moreover, the big dams have mostly been unsuccessful in controlling the floods at the time of excessive rainfall. Ninth, hence, we can say that sedimentation, which also meant that the floodplains were deprived of silt, a natural fertilizer, further adding on to the problem of land degradation. And 10th, it was also observed that the multi-purpose projects induced earthquakes, caused waterborne diseases and pests, and pollution resulting from excessive use of water. So, this was all about the concerns regarding the multi-purpose projects and the large dams. Now, let us finally move on to talk about the concept of rainwater harvesting. So, many thought that given the disadvantages and the rising resistance against the multi-purpose projects, water harvesting system was a viable alternative, both socio-economically and even environmentally. In ancient India, along with the sophisticated hydraulic structures, there existed an extraordinary tradition of water harvesting system. In hill and the mountainous regions, people built diversion channels like the gulls or kuls of the western Himalayas for agriculture. The rooftop rainwater harvesting has commonly been practiced to store drinking water, particularly in Rajasthan. In the floodplains of Bengal, people developed inundation channels to irrigate their fields, whereas in arid and semi-arid regions, the agricultural fields were converted into rain-fed storage structures that allowed the water to stand and moisten the soil, like the khadans in Jaisalmer and the johads in other parts of Rajasthan. In the semi-arid and arid regions of Rajasthan, particularly in Bikaner, Falodi and Barmer, almost all the houses have traditionally had underground tanks or tankas for storing the drinking water. The rainwater can be stored in the tankas till the next rainfall, making it an extremely reliable source of drinking water when all the other sources are dried up, particularly in the summers. The rainwater, or parlor pani as commonly referred to in these parts, is considered the purest form of natural water. Today, in western Rajasthan, sadly the practice of rooftop rainwater harvesting is on the decline, as plenty of water is available due to the perennial Indira Gandhi Canal. Rooftop rainwater harvesting is the most common practice in Shillong, Meghalaya, and nearly 15 to 25% of the total water requirement of the household comes from the rooftop water harvesting. In many parts of rural and urban India, the rooftop rainwater harvesting is being successfully adopted to store and even conserve the water. In Gendathur, a remote backward village in Mysore, Karnataka, villagers have installed in their households rooftop rainwater harvesting system so as to meet their needs. And nearly 200 households have installed this system, and the village has earned the rare distinction of being rich in rainwater. Tamil Nadu is the first state in India which has made rooftop rainwater harvesting structure compulsory to all the houses across the state. There are legal provisions to punish the defaulters. So, after discussing about all this, let us finally move on to talk about the bamboo drip irrigation system. So, in Meghalaya, a 200-year-old system of tapping the stream and spring water by using bamboo pipes is prevalent, which leads to about 18 to 20 liters of water that enters the bamboo pipe system, gets transported over hundreds of meters, and finally reduces to 20 to 80 drops per minute at the site of the plant. So, this was about the bamboo drip irrigation system.